The question says, Rahman is researching the heights of male giraffes in a particular region. Rahman assumes that the heights of male giraffes in this region are normally distributed. He takes a random sample of 8 male giraffes from the region and measures the height in meters of each giraffe. These heights are as follows. So we have all these data points. So in part A, find a 90% confidence interval for the population mean height of male giraffes in this region. All right, so we want to find the confidence interval. We're going to start by finding the sum of the terms k and also the sum of squares of the terms. Okay, so I'm going to use my calculator for this. I will go to stats mod. So shift mod stat, that's 3 and option 1. And then I'm going to put in the data points. So we've got here 5.2, enter, 5.8, enter, 4.9, enter, 6.1, enter, 5.5, enter, 5.9, enter, 5.4, and 5.6. So these are the data points. So shift 1, sum is option 3. So for the sum of the terms, that's 2. We get 44.4. So we've got 44.4 here. And for the sum of squares, I'll do shift 1, 3, option 1, 247.48, 247.48. So that's what we have right here. I'm going to calculate as well the sample mean, which we find by sum of x over n, right? So in this particular case, that's going to be 44.4 divided by the sample size is 8. And we're getting here 5.55. So we have x bar being equal to 5.55. We also need to calculate the unbiased estimate for the population variance, which is 1 over 8 minus 1, that's 7. Sum of squares, which is 247.48 minus 44.4 squared over 8. All right, so s squared is going to come out as, let me do the quick calculation. And this gives us 0.1514, 0.1514, and so on. Okay, so that's what we're getting right here. So we now have all the important things that we will need for calculating the 90% confidence interval. So I'll say for the 90% confidence interval, I think there's one more thing we need to find, which is the critical t value. Degrees of freedom is 8 minus 1, so that's 7. And since we have a 90% confidence interval, the p-value will be 95%, so 0.95. All right, so let's also find this. All right, so let's go to the tables. And here on the tables, we are saying 7 degrees of freedom and 0.95. So this should correspond to this value here, 1.895. So we now also have this important piece of information. All right, so the confidence interval, 90% confidence interval is calculated. X bar, which is 5.55 plus or minus the critical T value, which is 1.895. And that's of the square root of, and we have s squared, which is 0.1514, and that's going to be over n, which in this case is 8. So that's what we'll be having. All right, so we will now get the interval values. All right, let's start with 5.55 minus 1.895, and that's times the square root of ants over 8. Let's just put in the value. All right, let me just 0.1514, and that's over 8. Okay, we get 5.29 to 3SF. So 5.29. And the other one, we put a plus. All right. And we get 5.81. So 5.81. All right, so this is what we get for part A. Let's go on to part B. Part B says Rahman claims that the population mean height of male giraffes in the region is less than 5.9 meters. Test at the 2.5 significance level whether this sample provides sufficient evidence to support Rahman's claim. All right, so the null hypothesis is that the mean is 5.9. The alternative hypothesis is that, well, it's less than 5.9. The critical T, actually, the test statistic T is X, or let me rather put it this way. If the null hypothesis is true, then the sample mean will follow a normal distribution with the mean mu 5.9 and S squared over N. N in this particular case is 8, right? So like this. So we can find the test statistic, which is T, which will be X bar, the sample mean. Sample mean is 5.55. All right. So 5.55 minus the mean mu, which is 5.9. And that's going to be over the square root of S squared, which we got to be 0.1514. So 0.1514 over N, which is basically 8. All right. So that's what we'll be having. So the test statistic will come out as, I'll do the quick calculation here. We get negative 2.544. So negative 2.544. All right. Now we need the critical value, and that's the critical T value at 7 degrees of freedom. And we also have the P value, since it's a 2.5 test, then the 100 minus 2.5 is 97.5%. So 0.975, right? And the critical T value here is going to be, let's go to the tables. So here we're saying 7 degrees of freedom and 0.975. So it corresponds to this value here, 2.365. So 2.365 is what we are working with. Okay, so basically we are saying it's in the, if we look at the T distribution curve, it's like this. The test is a lower tail test, and we have 2.5% significance level. And we know that the critical T value, since it's in the negative, it will be minus 2.365. And the test statistic is minus 2.5, which makes it lie in the rejection region, because we are saying that minus 2.544 is actually less than minus 2.365. Therefore, it lies in the rejection region where we reject the null hypothesis. All right. So if we're rejecting the null hypothesis, it means we accept the alternative. We accept the claim that the population mean height is less than 5.9. So we can say that there's sufficient evidence to support Raman's claim. So that's how we perform the test right here, and that's how we do it.